Welcome to the channel Physics Fun. Physics Fun. Today we will start the third part of the Newton's laws of motion, and this content is directly connected with the Neet and GEE topics. So first topic today is equilibrium of a particle. Equilibrium of a particle. Equilibrium of a particle. Here, the equilibrium of a particle, we first understand what is concurrent force. What is concurrent force? Concurrent force. Let us consider a particle. That particle is A. Here, a force F1 acting on the particle, another force F3 acting on the particle, and another force F2 is acting on the particle. And that due to action of those forces, the particle is at the static condition or at the equilibrium position. That forces F1, F2 and F3 are called the concurrent forces. Those forces are called the concurrent forces. And here, equilibrium of a particle, we learn a law, theorem, the Lami's theorem. Lami's theorem. Lami's theorem. Lami's theorem. What is that? We draw the forces, that is F1, concurrent forces. Consider it F1, F2, and that is F3. This is F1, this is F2 and F3. This angle is alpha, that angle is beta, and that angle is gamma. Now what is the Lami's theorem? That force F1 by sine of the angle, opposite angle, that is sine alpha, okay, is equals to F2 by sine of the opposite angle, that is sine beta, equals to F3 by sine gamma. That is the Lami's theorem. That is the Lami's theorem. Now let's take a problem directly connected to Lami's theorem. Let's take a problem. Okay. Let us draw. This is the roof of the house, the wall of the house. Okay. Now let us take, this is two wires and another wire is connected to a block at equilibrium. Connected to a block that is at equilibrium. That's weight is, mass is 30 kg. And here this angle is 90 degree and this angle is 37 degree. Now find the tension on the each string. That is, here we consider that is T1, that is T2, and that is T3. T3 means here that is the force. This is the mg. It is 30 into 10. That is a 300 Newton. Now find T1 and T2. How to find it? Let's extend it. I extended it. If this is 37 degree, it should be 37 degree, right? But this angle is 90 degree. So 90 plus 37 degree, total angle is 127 degree, right? Now here this is 90 degree, that should be 90 degree. Now one angle is remaining. How to find it? Total is 360 degree. So naming it A, B and C. Now angle ABC is equals to 360 degree minus 90 degree minus 127 degree. Now we have 360 degree minus 217 degree. Now here we have, this is 3 2 4 and 4, and this is 143 degree. 143 degree. This angle is 143 degree. Now applying the Lamis theorem. We'll get T1, the opposite angle is sine 90 degree, is equals to T2, my opposite angle is sine of 127 degree, right, is equals to mg, that is the weight 300 Newton by sine of 143 degree. Okay, now moving, sine 90 is 1, so T1 is equals to 300 by sine of 143 degree. That is sine of 143 degree means sine of 180 degree minus 37 degree. That will give you 300 by sine of 37 degree. When we put the value, we'll get the T1. Now accordingly, when we get T1, we easily get T2. T1 is equals to T2 by sine of 127 degree, that is sine of 180 degree, that is 90 degree plus 37 degree. Okay, that is equals to T2 by, this is 90, so cos of 37 degree, because sine lies in the second quadrant, and in the second quadrant sine is positive. So we have T2, that is T2 is equals to T1 into cos of 37 degree. We'll get the value of T2 from that equation. Let's move to the another vital topic, is the analysis of the Newton's laws of motion. In connected bodies problems based on the normal reaction. Let's take an example. Let's take an example. Two blocks, one is 1 kg and another is 2 kg. One is 1 kg and another is 2 kg. Now a force 6 Newton is applied on the body. Find the reactional force acting between them. To solve it, draw it again. This is the first block that has a mass of 1 kg and another block of the 2 kg. A 6 Newton force is applied. In that cases, first we find the acceleration of the system. Is the acceleration of the system. Acceleration of the system A is equals to force by total mass 1 plus 2, that is 3 kg, that is equals to 2 meter second to the power minus 2. Okay, now we find the acceleration of the system. Acceleration of the system is A equals to 2 meter second to the power minus 2. Now a reactional force acting between them. Reactional force, here the reactional force is R1, here is the R1. Now considering the first block that is 1 kg, a reactional force of R1 due to the block 2 and the force is 6 Newton. Okay, and the block is moving in that direction. So here we have 6, the resultant force 6 minus R1 is equals to, from the Newton's laws of motion, is equals to m into a. The mass is here 1 kg, 1 into 2. So here we have minus R1 is equals to 2 minus 6. That is, we have R1 is equals to 4. As the reactional force is 4 when the 6 Newton force is applied on the 1 kg. Now reverse the force. Let's take here the block of 1 kg. This block is 2 kg. Force of 6 Newton is applied on the 2 kg. Acceleration of the system is same. A is equals to 2 meter second to the power minus 2. But the normal reactional force, it is acting, this is, let us consider R2, okay, and for this 2 kg reactional force is R2. Now considering the 2 kg, considering the 2 kg, R2 is the normal reactional force and here is the 6 Newton force, and the body is moving in the left direction. So 6 minus R2 is equals to m into a, mass into acceleration. Mass is 2, here mass is 2, acceleration is 2, so we have, that is 4, and minus R2 is equals to 4 minus 6, that is R2 is equals to 2 Newton. Here the R2, that is the normal reaction force, is 2 Newton. Okay, let's move to the fixed pulley cases. Fixed pulley. Now first draw the pulley. This is fixed here, a string is connected to two bodies. This is M1, that is M2. Just recapitulate it. And a force M1G, that is M2G, acting in the downward direction. Tension is T, that is tension is T. For the first body, we write it T minus M1G is equals to M1A, where M2 is greater than M1. And for the second body, M2G minus T is equals to M2A. From here we find the acceleration is M2 minus M1 by M1 plus M2 into G, the acceleration, and tension was 2M1 M2 by M1 plus M2 into G. Okay, now that was the expression of acceleration, the tension. Now let's change its condition. It is a table, right? This is a pulley, a thread connecting two blocks. It is M2 and this is M1. Now here M2 is greater than M1. Now find the tension and the acceleration of two blocks. How to find it? M2 is greater than M1, so the movement is in that direction. Movement is in that direction. Okay. Now this is M2G and the tension in the upward direction T, and here the tension in that direction T. Now for the first block M1, here is no weight should be considered because it is kept on the horizontal table. So here only T is equals to M1 into acceleration of the thread or the bodies. This is the first equation. And for the second block, we have this is moving in the downward direction. So M2G minus T is equals to M2A. That's the second equation. Now solve it, just replacing the T, we have M2G minus of M1A, that is equals to M2A. We have just M1 plus M2 into A is equals to M2G. So A is equals to M2 by M1 plus M2 into G. That's the acceleration of the system. Now let's move to the wedge problems. Let's take an inclined plane. Inclined plane is A, that is B and C, and the inclined plane making the angle theta with the horizon, and here is a pulley. There's a pulley, fixed pulley. This is a block, this is another block, right? This is M2, this is M1, this is M2 and that is M1. Now here is the different condition. Consider M2 is greater than M1, considering. So the movement of the system in the downward direction, and for that this direction. Now the forces acting on the M2 is M2G and the tension in the upward direction T. And for the second, the tension is T, right? Now the weight is acting in that direction, that is M2G. Now resolve it. From the inclined plane, we have the equation for the m1 mass is T minus m1g sine theta is equals to m1a, and for the second block the m2g minus T equals to m2a because it is coming down vertical. Now solving it, we have m2 minus m1 sine theta into g, that is equals to m1 plus m2 into a. The acceleration is equals to m2 minus m1 sine theta by m1 plus m2 into g, that is the acceleration. And putting the acceleration in any one of the equation, we'll find the tension of the string. So all for the day, and we'll discuss another JE and the Neet topics later on for the next class. Please share, subscribe and like my videos to enhance my enthusiasm. So goodbye for the day and stay tuned.